Hi everyone, I hope you are doing well. So in this video, we are going to discuss Leetcode problem of the day, and today's problem of the day is element appearing more than 25% in sorted array, and it is an easy level problem. So I believe the title itself has given away the whole problem details, and we don't even need to read this particular description. So anyways, it just says that we have been given a sorted array, and there there is exactly one integer that occurs more than 25% of the time, and we have to return that integer basically. Now the most important thing in this particular problem is the sorted array, and how does it really help us. So you see, whenever the array is sorted, so all the same values, let me take this example 1 2 2 6 6 6 6 7 and 10. So all the same values, that is 1 here, and then 2 here, and then 6 here, and then 7 and 10 here, right? All the same values occur together always, right? So this is a very basic thing about a sorted array. Now I know that if they occur together, then I can easily count the number of their occurrences, right? And it says that there is exactly one integer which occurs more than 25% of the time. That is, if I have n elements, there will be only one integer which occurs more than n by 4 times, right? So I can just count the frequencies of all of these elements and just tell which of them occurs more than n by 4 times. So how do I actually count it? Now this is also a very popular technique used at many places. So what I generally do is, I'm just going to traverse from the starting and go till end. As soon as I encounter an element which differs from the previous element, let's say this particular index, right? So I see that this particular element is different from the previous element. So in this particular case, I will reinitialize my count to 1, right? That means I am finding a new element now, and before initializing, I'll update my best as, let's say I'm just trying to find the maximum value, best as maximum of best comma count. How, right? So count will basically store the frequency of the previous element that was there. So let us just quickly do a dry run of this particular sample test case. So initially we are at this particular position, right? So I initialize my count with 1, right? I'm going to start my for loop from this particular position, right? So I see that the elements are different. That means the previous elements have ended and its count is 1. It is not greater than n by 4, so we just continue, right? We initialize the count to 1 again, right? So count is equal to 1. Now I come to this particular position, the previous and the current element are same, so I increment my count, so my count becomes 2. Now I come to this particular position, I see the previous and the current elements are different. That means the previous element has also ended, and currently the count is 2. So you see there are 2 elements, so our count is 2, right? Since the elements are different, I need to reinitialize my count with 1, so my count again becomes 1, right? Now I'm at this particular element, I move to the next element, I see that these elements are same, so I mark my count as 2. Again, next element, the previous and the current values are same, I increment my count to 3. Again, I come to this particular element, the previous and the next elements are same, I increment my count to 4. And when I come to 7, I see that these two elements are different. So I see my count value is 4 currently, and these 4, there are 4 elements which are equal to 6, right? So you see my count variable is able to maintain the frequency of the previous element, right? So now I see that this particular element is present 4 times, which is like in this particular case there were a 1 2 3 4 5 6 7 8 9. So 9 by 4 is equal to 2. So this particular element is present strictly greater than 2 times. That is why we can return this particular element. And in all of these problems, you would generally see that we are comparing the current element with the previous element. But let's consider a case like this. So you see, the condition where we check whether the current element is not equal to the previous element will never get triggered, right? So there are actually 2 solutions to this particular problem. That is, the first solution is you add an element to the end of the list which will never occur in the array. So this can be anything which you believe will never occur in the array. For example, in this particular case, we know the array of I is equals to is like greater than 0. So I can include -1 because I know that -1 will never be present in the array. Or instead of doing this, we can perform the same operation that we were performing in the if condition. When the current and the previous elements are not same, we can perform the same condition at the end, right? So you see here what I have done is, I have initialized my n with the array of size, and I have initialized my need value with n by 4. That means I need at least this much amount of elements, and I have initialized my count with 1 as well. So I am traversing through the array. I initialize my I with 1 and I compare whether array of I is not equals to array of I minus 1, right? And if this is the case, if count is greater than need, then I can just directly return this particular previous value. So remember why I am returning I minus 1, because count indicates the frequency of the previous element. Now I need to reinitialize my count with 1, otherwise if this is not true, I am just going to increment my count. So at the end I am just going to return the last element, the reason simply being that the question mentions there is at least one like integer in the array which occurs more than 25% of time. So if none of the other elements triggered this particular if condition, that means this is definitely going to do it, right? If this condition was not there, that at least one element will be there, our simple modification would be to add this particular condition. If count is greater than need, then only we are going to return this last element, right? So this was it for this particular video. Let me just quickly submit this and show you that this particular code works. So you see it passes all the test cases and the solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to share thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you and if you were to reach much more people like you who want to keep solving your problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.